Good evening, everyone. My name is Giselle Font. I am a master's student at the University of Chile, actually working at NIC Chile Research Labs, and I'm going to present today a work in progress in location privacy for a monitoring system of the quality of access to mobile internet. So first, I'm going to give you some context. A few years ago, NIC Chile Research Labs developed Atkinson Mobile, a passive monitor, which main goal is to measure the quality of access to mobile internet. So here is the overview of the system. So we have basically two main components: a client application that runs on volunteer smartphones, and a server application that collects data. The client application periodically collects data such as phone identifier, timestamps, byte sent and received, type of service, or antenna identifiers. So then this data is sent to the collector, and from data of multiple users, researchers can compute aggregations to study, for example, the quality of access to mobile internet in different areas of the cities. What users may not know is that from antenna identifiers, their location can be deduced. And even though there is no malicious intentions among our researchers, it is possible for them to recover mobility patterns of individuals using the application. So the question is how to protect location privacy of users while allowing for researchers to compute aggregated data. We propose a model where researchers can access, query, and compute aggregations on data, learning nothing more about users' location than the result of the aggregation. So how is that? Antenna identifiers contain the location information of the users that we wish to hide. Our model uses homomorphic encryptions to encrypt antenna identifiers in the mobile devices before being sent to the server. Then the rest of data remains in plain text. Then when a researcher wants to compute an aggregation, he sends the request to the collector. Since we use an homomorphic encryption scheme, the aggregation is computed directly in the ciphertext. Then only the result of the aggregation is disclosed to the researcher. How does it work? Imagine that each of these points represents an antenna. And now imagine that the mobile device takes a record in antenna 4. Then we will simply encode our antenna with a bit string with a 1 in the corresponding position of the antenna, or a 0 otherwise. The bit string is encrypted and ready to be sent to the collector. The collector has then a set of records belonging to different antennas that are hidden to researchers because they are encrypted. If you want to compute the aggregation, for example, count the number of records of antenna 4, the system computes homomorphically the summation of the fields in the corresponding column. So in our practical approach, we will divide our set of antennas in multiple zones. Then for computing the aggregation, we first filter by zone. Then, as explained before, we compute the summation of the desired antenna. This is possible to be implemented with a partial homomorphic encryption scheme with additive homomorphism. In this setting, researchers can learn the zone of the record but not the antenna. Another approach is to encode and encrypt not only antennas but zones as well, and divide zones into subzones, and so on. We will then have lambda levels of zones to compute the aggregation, to compute then we compute the product of the different zones, and then the summation of the results. To perform both addition and product, we need then a fully homomorphic encryption scheme. So we are actually working on the implementation of the modules of our model, and once finished, our goal is to test the system to evaluate the overhead of the location privacy for different settings of the parameters of our model. So if you have any questions or comments, I'll be pleased to talk to you later. So thank you.